into this explainer because today we are peeling back the drywall to reveal the intense, heavy-duty engineering hidden behind your everyday laundromat. We aren't just looking at a room full of washing machines here. We're going to see exactly what it takes to design, engineer, and build a high-production commercial laundry facility, right from the ground up. It's a journey that turns a quiet, empty room into a roaring engine of utility.
Now, when most folks think about opening a laundromat, they probably imagine signing a lease, throwing down some nice flooring, and plugging in a few rows of appliances. But the reality? Transforming a simple commercial space into a high-yield facility is a massive, highly technical undertaking that can easily reach nearly $1.8 million on the high end. It is a staggering number that catches a lot of first-time investors completely off guard. But as we break down the engineering step-by-step today, you'll see exactly where every single dollar goes and why it's absolutely crucial for the business to survive.
So let's start with the physical constraints of our blank canvas. We're looking at a deceptive 3,878 square foot empty shell in Lakeland, Florida. Right now, it's completely devoid of plumbing, mechanical, or electrical fixtures. It's what developers call a vanilla box, a blank slate just waiting to be completely re-engineered. On the surface, nearly 4,000 square feet sounds like a massive amount of space, but as you'll soon see, once you factor in the sheer volume of infrastructure required, that empty room is going to shrink incredibly fast. So, how exactly do we get from that empty box to a finished, fully compliant facility? Well, here's our architectural blueprint for today. We'll start with the blank canvas, move into the geometry of profit, check out flow and compliance, examine the lungs of the building, and finish up with that $1.8 million reality check. Starting off with Section 1, the blank canvas and the deceptive simplicity of a vanilla box. Our starting point is a 104-foot by 37-foot rectangle. Think of this like a high-stakes game of Tetris. We have less than 4,000 square feet to balance incredibly heavy, vibrating machinery with human comfort, accessibility, and intense utility loads. Every single square inch has to be optimized. You simply can't just throw machines wherever they fit. The spatial logic we apply to this rectangle dictates the entire operational flow of the business, effectively locking in its profitability before the front doors even open.
And behind those spinning machines, you have to upgrade this basic floor plan into what's basically an industrial utility plant. I mean, standard commercial concrete slabs, they would literally crack and crumble under the intense G-force extraction cycles of those 80-pound industrial washers. So we've got to carve out the floor and pour newly thickened concrete slabs just to handle the massive vibration. On top of that, you need huge 4-inch sewer lines to handle simultaneous discharge from dozens of washers all at once, a high-capacity 2-inch water line, and specialized 3-phase electrical power. You're basically building heavy industry disguised as a retail storefront.
Now for Section 2, the geometry of profit, focusing on island and perimeter spatial logic. By grouping washers right in the center of the room to share a massive 48-inch plumbing trough and pushing the dryers to the exterior walls for easy outside venting, this island and perimeter layout is an absolute masterclass in efficiency. It dictates exactly where the utilities need to flow before a single wall is even framed, effectively cutting your plumbing and venting runs in half. And putting those dryers on the perimeter? That means the hot exhaust has the shortest possible path to the outside, saving you huge amounts of money on ductwork and mechanical boosters. But the real secret to that geometry is what the customer never sees. You absolutely have to prioritize this hidden utility corridor. It's kind of like the backstage of a theater. A 48 to 60-inch chase allows maintenance to happen on main gas headers and water lines without ever shutting down the customer floor. So, if a valve needs replacing, a technician simply walks behind the wall, makes the fix, and the customer out front has no idea there was even a problem. It's essentially the hidden engine room keeping the whole operation alive.
Moving on to Section 3, Flow and Compliance, where we design for ADA and human movement.
You know, the rhythm of the spatial math here is strictly required by the Florida Building Code. We aren't just moving people. We're moving people carrying massive, heavy laundry carts. If you fail to account for these 72 to 84-inch cart zones, the 48-inch machine row clearances, or the mandatory 60-inch turning radii for ADA compliance in the restrooms, well, you simply don't get your permit. Period. The math is non-negotiable. It forces architects to carefully orchestrate this seamless dance between the stationary equipment and the constant, unpredictable flow of human movement. So we constantly have to balance high-yield public revenue areas against the necessary back-of-house infrastructure across these 3,800 square feet. While 58% of the space generates revenue on the public laundry floor, over 40% of the building is completely consumed by production, amenities, and essential ADA compliance spaces. Every square foot is a literal tug-of-war between profit and code. Sure, you might want another row of washers to boost your income, but if it eats into that mandatory restroom turning radius or narrows a primary cart aisle, you have to sacrifice the equipment.
Okay, Section 4. The lungs of the building, looking at industrial exhaust and airflow systems.
Here's a wild thought. A laundromat actually breathes. Managing heat and moisture isn't just about making sure customers are comfortable, it is quite literally about the structural and operational survival of the facility. You cannot just pump massive amounts of hot air out of a building without bringing fresh air back in. Without a dedicated makeup air system, the building develops severe negative pressure. That makes the front doors incredibly hard to open and causes catastrophic equipment failure because the machines are practically suffocating trying to draw air that just isn't there.
Think of this delicate airflow cycle like a giant set of lungs. As the commercial dryers push massive amounts of exhaust air out through rigid steel ducts, a vacuum starts to form inside the shell. To counter this, those interlocked makeup air intakes automatically open to pull fresh air in, replacing the exact volume of air lost. They have to operate in perfect harmony. Every cubic foot of air pushed out by a dryer must be immediately matched by a cubic foot of fresh air pulled from the outside.
Because if they don't operate in harmony, you run into a terrifying scenario known as backdrafting. To put it bluntly, failing to engineer the lungs of this building properly means that negative pressure will pull exhaust gases like carbon monoxide from your water heaters or gas dryers right back down the flues and into the customer area. It instantly turns a profitable business into a massive life safety hazard. And that's exactly why mechanical engineers spend so much time calculating the exact cubic feet per minute of airflow required for these spaces.
And finally, Section 5, the $1.8 million reality check. Let's add up the MEP and equipment costs.
When you compare a standard vanilla box retail store to a laundromat, the scale shock is incredibly real. A standard retail spot just needs basic AC and maybe a 1-inch water line. But laundromats? They demand high-recovery water heaters, complex makeup air systems, massive 4-inch sewer upgrades, and heavy-duty gas manifolds. It's a completely different league of construction, which really explains the massive mechanical bill we're about to look at. You're basically dropping a small factory inside a strip mall, and plumbing and electrical contractors have to price their work to match. So where exactly does that $1.8 million go? Well, construction and mechanical fees completely dominate the project. You are easily pushing past $1 million in hard construction costs and contractor fees before you even buy a single washing machine. The hidden infrastructure alone is the biggest investment you'll make. It's so easy to obsess over shiny new appliances, but the real capital is buried in the concrete, hidden behind the drywall and suspended up in the ceiling.
And here is the heavy machinery driving that massive utility load. The sheer capacity of this equipment, from 8 20-pound washers all the way up to 4 80-pound mega washers, plus 18 stacked gas dryers, it's just staggering. This exact equipment list is why we need the intense architectural, spatial, and mechanical footprint we've been walking through today. Each one of these heavy-duty units demands its own perfect share of water, electricity, gas, and airflow just to function at peak efficiency.
Ultimately, what we've learned is that you aren't just designing a room and plugging in some appliances. You are engineering a high-capacity, heavy-duty processing plant that just happens to operate seamlessly for the general public. The infrastructure requirements completely blow past standard commercial spaces. Every single choice, from the thickness of the concrete slab to the width of the plumbing chase behind the wall, is a calculated engineering decision designed to keep this massive industrial machine running smoothly, day in and day out. So as we wrap up this explainer, I want to leave you with a thought that might just change how you view these everyday spaces. The next time you drop a coin in a washer, take a second to look down at the floors, look up at the ceiling vents, and ask yourself, are you standing in a simple retail store or a multi-million-dollar utility plant? Thanks for diving into the blueprint with me.